Hey, ROS developers, you are here back again for a new live show here today. And today we have the second part of the webinar that we have the last week, where we were doing some OpenAI and how to apply it to make it ROS robots learn using OpenAI. Okay, so last week it was quite a definition session, but today is a completely practical session. So what we are going to do is to go straight to the exercises, and you are going to follow with me, okay? So you had to follow the instructions. You have to follow the steps that I am doing. I will be keeping an eye on the chat there. And so if in case that you have questions, so we'll be doing a kind of a class. So it's a live class, okay? So in theory, all of you have received the files that are required in order to do the exercises today. And in case you are not, because whatever the reason, I don't know, don't worry, you will be able to receive them by the end of this webinar. So you will have to wait until we finished. Okay, so for the others, are you ready? Everybody's ready? Tell me something on the chat. Are you ready to follow my instructions? Say, yes, I am ready. I am eager to learn today here how to do OpenAI with ROS. So that's amazing combination, you know, the best of artificial intelligence with the best of robotics, OpenAI and ROS, and everything using our environment, you know, the ROS development studio, that is the development studio that we built here at the Construct as one of the tools for making people learn about ROS and how to program the robots. Not to save the files. I'm sorry, Scamanyambas. I don't know what is the problem, but we'll figure out after the live show, okay? So I see some yes there on the chat, and then let's go for it. So I'm going to share my screen with you. In the meantime, I'm going to hit the one that missed. So I'm going to share this, my screen. So how do we start? How do we start? Okay, first thing. So you probably are not on that screen. So you had to go and visit the RDS, okay, the ROS Development Studio. The address is rds.theconstructsim.com. So you got it there. Yeah, so if you are there, you should appear and you log in. I'm already logged in. So you should appear in a screen like this one here, where you contain all your personal projects. If it's your case that you don't have any personal projects, then it will happen that you are in the public zone, where you have several public projects, and some other people have published already some public projects that you can check if you want. And those are people not from the Construct, but some other people there. So anyway, we go to the My Project zone here, and then you look for the project that I sent to all of you. So I have shared this project from here. So when I created this, at the beginning of this week, I created this project, and then I pressed this button here, share, and then here I typed all your email address. So I share it. So I see here that the Scamanyambas has no file. So if you can put your email here on the chat right now, I mean the email that you used to log into the ROS Development Studio, I can share that with you right now. But you have the chance just right now. If we have to wait, so then we don't have time for that, because the rest of the people are waiting. So then I put all your emails that you send me on the email. So I put them here, and then I press share files. This file was shared with all of you, and that's why you receive on the RDS. Okay, I see that. Oh, here it is, Scamanyambas. Great. So let's try in real time. And Pekotsu Petroshu also. Okay, so let's do it. So let's put it here. Scamanyambas and Petroshu. Okay, a lot of other people there are taking the chance. Okay, great. That's the way. That's the way. So I'm copying all of you here, and we have Dennis also. That's the last one. And Avinash, okay, you got in the nick of time. Okay. Then I also see the comment of Arnaud that he is already been able to log in. He had some problems and we were discussing about that. I'm happy Arnaud. So let's follow. Great. No more time. Then let me share the files with you. So I am sharing this with all those users. The files have been shared correctly. So the new guys, those of you who just arrived, if you go to the RDS, you should see this project here, okay? So everybody there, go to this project and press open project, of course. Then it says a description, what it's about, etc. Then you open. Yes, we have this little pop-up here that is very annoying. I don't know what is this. This is new of today, so I don't know what is happening. But in any case, you press OK on that pop-up. I don't know what it is, and don't worry, it's not important. And then we get into this window, ROS Development Studio. It's an empty window. Okay, so what are we going to do today? What we are going to do is to train a drone to move autonomously from one place to another point, or a specific point, while avoiding an obstacle. And we are going to use OpenAI for this. So I'm going to show you how we have structured this learning. And the first thing that we have to do is to see what is actually what we want to do. So let's go to the funny part first. Okay, so the funny part is that we are going to see what are the packages for that. Let's go to Tools and select a shell. Then I'm going to put it here. It's easier for me. Then here, if you have a LS, you will see that there are several workspaces. The one that contains the code that I have shared with you is the Catkin workspace. The other notebook workspace is for notebooks. The simulation workspace is for simulations that you can build. But now we are building code, ROS code. So that goes to the Catkin workspace. So I'm going to go to the Catkin workspace. You follow with me, okay? And you tell me if you get stuck at some point. And here we have a drone training package. That's the package that I have shared with all of you. And you see that there is some code, okay? So let's do the funny part first. And let's launch this drone training code. But before we launch it, we need a simulation. The simulation that we are going to use to train the robot. I mean, there's the drone. Then in that case, you have two options. First, you create your own simulation and you put it here on the simulations workspace, or you launch one of the ones that is already built here in the ROS Development Studio that it's already provided for. Let's do that because it's easier, of course. So let's go to simulations. And then here, let's select the simulation of the parrot. You go down and here we have the parrot. So I just click here and then a new window opens. A new window opens and it's starting the simulation. It's a gazebo simulation with this drone. So we wait a few seconds until the simulation is completely launched. And then we'll have that. Okay, great. It's about to appear. Still finishing something. Okay, we look this. It should appear like a green field. And the simulation is running. It's still taking some time. That's strange. Usually it doesn't take so long. Let's see what is happening. So let's see. This is the simulation log. Okay, it contains all the logs related to this simulation that has been launched. And it's taking a long time, this. So I don't know, this is not normal. So this long time, for whatever the reason, sometimes gazebo crashes sometimes, and then we can do nothing because about that. So looks like has crashed in this case. So let me just launch it again. Just open again, simulations, parrot drone. So let's do it again. I mean, this is been tested many, many times before I send that to you. So don't worry if this happens. Sometimes, I don't know, the simulations just don't load. This is a normal behavior here. Yeah, okay, great. Great. So here it is. Okay. So here we have the simulation. Some people is saying on the chat that everything is working for them. Perfect. Yes, that's a normal thing. Okay. So here we have the environment, and this is the drone, and this is the environment. We want the drone to go from here to there, some place around there, and but while avoiding this and while keeping the lowest distance to the ground, so the closest distance to the ground, okay, because we don't want to get detected by the radars of the enemies or wherever. So that's a basic example, just an example. So let's launch the training example. For that, you go to the shell now that the simulation is loaded, and then you launch with this command, ROS launch, the name of the package that is called drone training, and then the launch file that is called the main.launch. If you launch this, then everything will start, and the robot, you will start moving. You can see that it's moving. This is the learning algorithm that is trying to get it and is sending the commands based on its learning. So at the beginning, the movements of the robot are random because the algorithm knows nothing. He is just exploring what he can do with the drone. As you can see, the erratic movement that the robot has is very funny. It looks like a drunk drone, isn't it? So it's trying to move, it's trying whatever he can do. And here on the shell, you can see the results of its trying, okay? And you can see that at present, we have done one episode, and now just finished the second episode, and then the robot starts again from the beginning. This is the episode 3, has started already, begins of the beginning. Some episodes are longer than another. You are going to see the reasons why in a few minutes. And whatever, we have here the result of each episode, okay, with the parameters that for the learning algorithm and the reward. The most important part is this, the reward. The reward indicates the amount of points that the robot achieved on that episode. And this is necessary for any reinforcement learning. Okay, so the robot is there running and running, and it will keep running for 10 episodes until now. So because it's how it's been prepared now, but you can change this very, very easily. Okay, so this is what we are doing. Okay, so now let's see how it is done. So you can modify, so you can adapt or change for your own robot, or even improve the training of this one, okay? Because I have some exercises for you that will reach that later. So let's wait until the episode 10 finishes. So I leave it there, okay? You also leave it. Then let's go to see what the package that I have shared with you, the one that is doing this, how it works. For that, let's go to the file system, to the IDE that we have integrated. In this case, you go to the tools and select the Cloud 9 here. That's the IDE. That's the system that shows all the packages and the code that we have. Okay, I'm going to increase the size of the font so you can see better. And let me close all that because many things there. And let's review together all the files. Okay, so here we have the Catkin workspace. That is the place where we have put our code. Then we have the notebook workspace that is empty, and the simulation workspace that is also empty. It contains nothing because now we are using the simulations of the system, of the RDS. So let's go to the Catkin workspace, and here in the source, we have the drone training. Inside this drone training, we have several directories. The first directory that I had to take into account is the launch file, this one here. The launch directory contains the main launch file, and this is you click here and you open it, then it's the one that launches when you have seen it on the shell. That, by the way, it has finished already because it has reached episode 10 with 450 score rewards. Negative is bad. So you'll see later. Okay, so it has finished. That's great. And then anyway, we go to the main launch. This is the one that has started. And what it does is first, it loads the parameters for the training algorithm from a config file, from this config file. Let me change this to XML so you can see better the different parts. So here it's loading into the ROS param server all the parameters required for the Q-learning algorithm. We are going to use a Q-learn algorithm for learning here in this example. So it loads the parameter into the param server of ROS, and then it launches our start training code that we are going to see in a minute how it works. So that's it. Does only this. The config is this file and is stored into this config directory. This config directory contains this file that contains all the parameters that you want to use for your training. This is important to keep in the parameters into a file, because you can generate different configuration files and then try the algorithm with different parameters. Parameters are very, very important when you are trying to teach some robot to do things. Actually, you will need to run many simulations with different parameters in order to tune the best way for your robot. So it's interesting that you keep those into different files. So you can have the Q-learn params version 1, version 2, and then also keep the score that each one is producing for you. So we have here in the config directory, the parameters, they are loaded here by the main launch. And then we have here the source directory. The source directory, you have several files, but the main one that you have to see, there are 3 main ones, okay? But the main one is the one that we have here in the main launch, that is the start training.py. Yeah, it's the one that initiates everything. And then I see that Petroshu has a problem. Cloud9 doesn't show my files. There are only 3 points. It's rolling, how glass? Yeah, probably is loading. For whatever the reason, you have some delay. Don't worry. In case that you have a problem on there still and persists for 1 minute, then press F5 on the browser and then refresh everything. And hopefully everything is solved. So I keep it on the source directory. We go to the start training. This is the file that has the main, of course, and is the one that performs the training of the algorithm. Okay, so the training, it's performed here. We are going to see how it works in a minute. And here also have the Q-learn algorithm file. That is the one that implements the Q-learning algorithm of reinforcement learning. You want me to increase the font of, I don't know if I can increase the font of the, here, I presume that you mean this. I can increase the font here, like this, maybe. Okay, so this is increase the font. So this is the Q-learn algorithm. And then this is the algorithm that is learning, actually. It's learning. And we are going to see where it goes. And also the other file, so we have start training, Q-learning, and the environment. The environment is the part, is this file here, this one. This is the one that describes the conditions for the reinforcement learning algorithm to work. So if you remember here from the last week, we have in a reinforcement learning algorithm, we have the situation, we have this situation. First, we have the agent that is the one that has the learning algorithm. In this case, the agent will be the Q-learning algorithm. It will be the robot, the drone that is running the Q-learning on its brain, let's say, okay? Then this robot selects an action and then it sends to the environment. Then this action could be, in our case, we have 5 different actions. It can go up, it can go down, it can go turn one left, right, or the other one, I don't remember now, we have to see there. I don't remember. There are 5. So you apply this action into the environment, and then you get a result. So the robot will move into one direction or another. As a result of that, you have a new state of the environment. That means the robot is in a different position and can detect different things. That's the state, okay? And based on that state, we calculate a reward. So this reward is the one that says how good this action was for in this environment for the task that the robot has to solve. In our case, the action will be move to one direction, up, down, right, left, whatever, with the aim to reach the other place here, the other place after this wall. Okay, so that's the task that it has to complete. So when we apply this action in that environment, this environment is the one that calculates the next state, that is where is now the robot, and how close is this robot to the goal that we want to achieve, to get it to the other side. So all that, the reward and the new state and the application of the action is implemented by the environment. And the environment is a class provided by OpenAI. OpenAI is the one that provides this class, and we have to fill with our current situation. So it means we have to fill it with the actual actions that the robot can perform, the type of environment, the type of robot, etc., etc. We are going to see that in a minute. Okay, so what else? Yes, that's the environment, and then it's described here. Then finally, we have here the training results directory. That is the one that contains some results from the learning. Those results have been just generated right now. So you didn't have this before you start this webinar. They have been generated by this running that we have done here once it reached the episode 10. Okay. Finally, we have another directory that's called utils, where we have a tool that allows us to plot those results. So do this with me, because we already have the results. Let's do a plot. Then in that case is you can go to that directory that is drive. Drone training. Then utils. And here you can execute the Python file plot results. And then it will generate a file showing how this training has improved with the different trials. Okay, so then it says here, opening plot in graphic Windows tools window. Okay, so it has opened the plot, that plot in a graphic tool window. Where is it? It's in the tools. If you go to tools, graphical tools, you press here, and then you will see the image that has been opened. Here it is. Great. So we have this image that is the one that contains the different rewards that it has obtained the training in the different episodes of training. So you have it there. Okay. So this is very, very bad training, because it only were 10 actions. I mean, 10 episodes, sorry. In order to get a drone, usually you require hundreds of actions. So that's some homework that you have to do, is to change the configuration file parameters and allow it for thousands. Let's not say thousands, but hundreds. Let's say 500 episodes. So how do you do that? You come here to the config, open the QLEARN parameters, and then you change here the number of episodes. Okay, so you would put here, for example, 500, and that will. Don't do it right now, because we are testing, and then it will take forever to finish. And well, you can do Control-C afterwards, but it's a little bit noisy. Well, okay, so now let's go to now that you know how to do this, let's see the code step by step so you understand how it works. Okay, so how do we start? So we start on the main launch. The main launch, what it does, it launches the start training. Okay, let's go and see what the start training code does. And here it is, the start training. It's first is the main here. So the first thing that it does is to initialize the node. So it's indicating that this is a ROS node. We need this in order to get access to the gazebo simulation through topics, and also in order to get access to the parameters, to the param server. So we initialize the node. Great. Now let's create the gym environment. So we are creating this environment here. And for that, we have created a class, a specific class that is called, let me see, where was it here? It's a class that it's called quadcopter environment, okay? So I'm not explaining you right now here, but the only thing is that you need to know is with this instruction, we are indicating to the gym, to the OpenAI gym, hey, please create all the content of that class and prepare everything so we can start doing the cycle. Okay, so we are going to see how it is done in a few minutes. But basically, we are creating this. We are saying the gym to create this. Okay, so what else? Then we start the login system. Okay, we say, hey, please put in that directory the results of every trial, and then go, you create this in the environment with a graphers monitor. This is the sentence provided by OpenAI that allow us to monitor the results, everything. So that's a login system in order to see those files that you just saw in the previous results. Okay, so this is some variables, and then we get the parameters, the important parameters for the learning algorithm. They are obtained here, and as you can see, they are obtained from the param server. This is the command to obtain a parameter that is called alpha from the param server. Actually, if you come here to the shell, let's go to the shell. Or, okay, so I'm going to close this, Control C. If you don't want it, you can launch another shell here. You can launch as many shells as you want. So I'm putting wherever. So I'm just economizing the time, but just showing you. Anyway, you can do a ROS param list. Here, this will give us all the parameters that are on the param server of ROS. And because we have launched that training file, you will see that those epsilon discount, gamma, all those parameters that are required for the algorithm, alpha, are loaded into the param server. Okay, so what are we doing here is just retrieving them. Then we are retrieving here, and once we have a parameter, we initialize the learning algorithm. That in this case is the Q-learning. Okay, and we provide to the Q-learning the parameters that we have specified, because we know that for this situation, those are the good parameters. Or maybe we don't know, so we just try and see what is the result. Okay, then some things here to say. First, to the Q-learning algorithm, we have to specify also the number of actions that are available to the drone. So here we have to indicate how many actions, different actions, we are able to do, the drone is able to do. In that case, if you remember, it was 5. Move up, down, left, right, and let me check it because I'm telling you it is here. And up, down, left, right, and forward. Okay, yes, and forward, of course. Yes. So this is the start training again. So when we create the Q-learning algorithm, we provide the number of actions. Remember, this is not which actions. The Q-learning algorithm is agnostic from which actions you are taking. He only wants to know the number, and then it will assign a number to each action. So we have 5, then the Q-learning algorithm will say, okay, we have action 1, action 2, action 3, action 4, action 5, whatever it means. He doesn't care. This is the first thing you need to know about the Q-learning. The second thing is that this Q-learn algorithm is not provided by OpenAI. Well, actually, there are implementations there in their code, but this one is your algorithm. So OpenAI, what it provides is the environment so you can test your algorithm without having to create the whole thing. And also, more important than that, you can compare in equal situations different algorithms. If instead of putting here Q-learn, you put your own algorithm, then everything will work again in the same way, and you can compare the results based on the rewards, okay? So in this case, we are using this Q-learn algorithm that is an implementation here on this file. It's an implementation made by Victor Mayoral from Robotics. He's a super crack. He's a very clever person, and he has created this implementation here that you can check on his Git. I will put a link to this in the notes of the video. And he has created here the class Q-learn that allows us to do the algorithm. So we don't have to create ourselves because it's already done. So thank you, Victor, for this. And what else? Yeah, so this is the class. Okay, so I'm going to close this file because today we are not going to concentrate on how this Q-learning works. Everybody knows how it works. Otherwise, if you don't know, you can check here at the Wikipedia. I will put also a link to this. And here it is described how it works, the formula of the algorithm, all the parameters, different versions, etc. Okay, so far so good. Great. So I'm going to close this to avoid things getting around. Okay, so we have created the algorithm, and now it's time to start the training. For that, we have this loop here. So with this loop, you start the training of the robot using this learning algorithm and using these parameters. Great. So how does it work? First, we have the number of episodes. What is an episode? I already explained. An episode is a trial. So we allow the robot to try to solve the task. The task is to move without crashing as low as possible, move to the other side of the wall. Okay, so that's the goal. And then we allow several number of trials, several number of episodes. And the number of episodes was configured here in the YAM file, as I mentioned. I have put now 5, but you probably have 10 if you haven't modified. So this is the number of times that it's going to train. Every time that it tries to achieve this, we allow the system to move for a number of steps. This is the second for loop. You see here is the number of episodes, and then is the number of steps. So the number of episodes is the number of times that it's going to try to solve, and then every time that it's trying to solve, how many steps we allow the robot to move in order to solve the task. Okay, so this is also another parameter that you can find here, is the number of steps. We are allowing up to 100. We consider that if the robot hasn't solved the task in 100 steps, then it means that it's not going to solve it. So too many. So that's another step, another parameter that you can configure. Okay, so here in the number of episodes, what we do after some variables that we need, the first thing that we do is that we reset the environment. This means, hey, please start the robot and everything in the world at the initial position, because we are going to try again from the very beginning. So that's the first thing. This is provided by OpenAI. This is a function provided by OpenAI, but that we have to implement in our environment class. Just some minutes. And then by this, getting this observation, we create the state. with the observation. Basically, state and observation for you should be the same. And the state is this. Okay, so we get the initial state, so we can feed that into the agent. This is the initial state. How is the world now when we start? And then based on this, we start trying. And the first thing that we do is to select an action based on the state. You see, if you remember here, we provide the state, and then the agent uses the state to select the next action. So that's what the algorithm does. So it asks the learning algorithm, hey, please choose an action. And then the algorithm says, yeah, the number 5. Okay, so we got the number 5 here, and then we execute the action in the environment, of course. So we provide to the environment the action selected, and we calculate that in one step of time, I mean. So it's this, the agent selects an action and provides to the environment, and the environment moves the robot in following the action selected into the direction that it takes for a certain step of time. Great. And then based on that, it calculates the reward. And again, the observation is the state again. So it calculates the reward and the state again. So how has the world changed? What then there is an information that says in Scamiambas, what is the information contained in a state? In that case, in this particular case, is the position of the robot in the x-axis. You are going to see now in a minute. So once we have done this step, we get the reward and the next observation. And okay, we calculate all the accumulated reward, and we provide this reward, state, action, and reward, and next state to the Q-learning algorithm. So the Q-learning can make the learning based on the results, as I explained here. So based on this state and reward, the agent algorithm can learn and then decide on a new action. So as you can see, it learns. If we are not done, because we are not done, then we continue to the next state. And basically here, just some variables for housekeeping, and we return back. So, and we repeat until we are done. Either we achieve the goal, or either we make too many steps. Or there is a third option, that is we do something very, very, very wrong, and then we consider that this is so wrong. For example, like in this case, is to have a certain inclination, or if you get up to 2 meters and you keep on moving up, then we consider that it's finished. So you don't, this is no point to keep trying. Okay, so basically this is that there is nothing more. Then when we repeat all the steps, we have finished that trial, and then we repeat again on another trial, depending on the number of episodes. And we keep a log of the amount of reward that we have obtained in each step. So let's repeat again the trial. Okay, so let's launch again this code. And now afterwards, we are going to go to the environment and see how the environment works. So let's go again with me to the shell, and then launch again the drone training. So now you can see what is happening, and you can understand what is happening, what you see on the simulation. Okay, so let's launch it. And the first thing that you will see is that the robot is initialized again at the beginning of the world. That's the initial position that we want to see. That is around here. And now it's on the first trial, on the first episode, and it's doing actions. As you can see, it is allowed to do up to 100 actions. It's the Q-learning algorithm that is selecting how those actions are taken. You see, and he's doing very stupid things because he knows nothing about the world. Okay. And then there is a a question by UR14, whatever your name, that says, where are we giving the Deseret state? Very good. This is a very good question, and it's provided into the environment. We are going to see now, because now we go to the environment. So you can see that when the robot has done the 100 steps, or done a very stupid thing, like moving very up or incline very, very much, then the current episode is finished, then the reward, final reward is generated, the total reward for that episode is generated, and then the robot starts again at the initial position because there is a reset. Okay, great. So here it is. And then it starts again, etc., 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 and then repeats, okay? So you get this idea. Then what else? So let's go. Now we have this, but we haven't explained how to create the environment and what the environment contains. So when we say here, hey, create Jim, OpenAI Jim, please create this environment. So what does it mean? Okay, so this environment has been defined into a file. Okay, your name is Austin. Okay, nice. There is a question here by Martijn that where is the training data safe? And where is the training data safe? Saved. Yeah, so the training data, no, it's not the training data, it's the result of the training. Is created here in the training results directory. Okay. Okay, and then there is a discussion here that about the state, what is the state containing? You are going to see now here in the environment. So let's go. When we say this, how does the Jim know what is this? Okay, so this is because we have imported here my quadcopter environment. That is the file that we have here, my quadcopter environment. So let's have a look what it has. Okay, so this file is the one that creates a quadcopter environment class that inherits from a Jim environment. Okay, so now you have one, you understand that this is a Jim environment, so it follows a pattern. It follows an API. It's a class that has to implement some functions specific that the environment is requesting. Okay, so the first thing is that we have registered here with this tag, this class as an environment available to the Jim. So because of this registration, when we decided here in the start training file, we say, hey, please, Jim, create an environment with this tag, then the Jim knows that, okay, you mean this, an environment defined by this class because of this sentence here, okay? Is the registration. Okay, so apart from that, this is housekeeping things. So let's go for the class itself. The class, because it inherits from an OpenAI Jim system, this is an environment, it has to follow certain rules. So it has to implement certain functions in the class. First is the initialization. We are going to see now how it works, but then we have to implement those three functions that I mentioned here. First, the seed function, that is a function to initialize the random generator, because all the algorithms, most of the algorithms, they need random numbers in order to operate. And this is a way, provides a way to initialize in the way we want the random generator. So, but the important functions are the reset function, that this is the function that we are calling here in the start training. If you remember, before when we start a new episode, then we say here, hey, reset, environment reset. So that's the function that we are defining here, the reset. And basically what it does in this case, it depends on your application, on your robot that you are training. So you have to define here. Then it's, in this case, we reset the whole simulation. So the robot gets into the initial position. And Then we also reset some topics and things in the robot and in ROS. Those are functions that are described below. You can have a look. And also we initiate the takeoff sequence. So for us, every time the algorithm starts a new episode, the robot has already taken off. So we start from a taken off position. And then we get the first observation based on the initial state and return this observation. So if you come here to the start training algorithms, when we do the reset, we set the environment and the robot at the initial conditions, and then we get the first observation of the state. Okay, great. No, here. Great, so this is the reset function that we have to define, the seed function we have set, and then the third one is the step. The step is the most interesting one because it's the one that takes the number of action that the learning algorithm has selected. It is a number between 0 and 4 in this case because we have 4 actions. So it takes this and then actually performs the action. So it makes the robot perform the action in the environment because we want to know what it is, what is happening. Okay, so in this case, this step function is called here in the start training. Start training, let me see, where is it? Where is it? I cannot see it. Oh, here it is. Okay, so we say, hey, environment, perform a step with this action. And this action was selected by the QLearn algorithm based on the state. Okay, so step, take this action and execute it. Then that's what this function does. It takes the action and it says, okay, so is the action number 0? That for the engineers, it means moving forward. But the algorithm doesn't care what it means. It is just an action number. So we set the velocity commands according to this action to forward. So we create this command that makes the drone move forward, and also for the rest, to move left, to move right, up and down. Okay, so we create this based on the action that we have received, and then we publish this velocity. So we apply this action into the robot. We allow some time for execute the action, so the robot is moving for a certain amount of time. That is also a parameter, this certain amount of time. And afterwards, we take the observation of the result at that point in time. Then, based on that data, observed data, we process that data and we calculate the reward here. In this function is where we calculate the reward, okay? So, and based on that reward, we also are going to modify that reward based on the actions that led us to there, because we want to promote going forward instead of turning, because we prefer that the robot goes fast, straight to the point. For that, this reward is going to be modified by some modifications that you can apply this. This is completely arbitrary. So you can produce this as you want. Maybe you can eliminate this also if you don't care about going forwards, or maybe you prefer that the robot is doing like a zigzag, and then you change the reward based on that. So you promote those kinds of behaviors in the robot. Whatever it is that you finally get the reward and you return it. So you return the state, that is the observation that we have taken here, the observation, after the application of the action, the reward, and either if it has been done or not. So if we have achieved the solution, okay? So it was a question there on the chat that, hey, where do we put the conditions for that the robot has achieved the task? Is this, the conditions are put here in this process data function that we have created. This is how I have organized this, but it's not required to organize in this way. This is personal way. But in any case, you have to create a function that provides a reward based on what the robot has done. What is the current state of the robot? Okay, so let's go to this process data and see how this data can generate a reward. Okay, so you will understand the really deep how it works. But before we go there, just let me say that I have finished with the main functions that you have to implement in your environment in order to be OpenAI compatible. Okay, so those are the rest of the functions are functions that we do for the simplification of those. So let's go to this process data. Okay, in this process data, we are providing the pose and the IMU values that we have obtained here in the observation of the environment after we have applied the action. Then let's go to the process data that is around here. Process data. Here it is. We have the data position and the data AMU. Then after some calculations of the data of the AMU, because it's in quaternion, so we have the values. Then we decide if the pitch and roll are bad, it means that the robot has inclined too much, or the altitude is bad, if the robot has also reaches too much altitude. In those cases, then we provide a -200 reward. We say, hey, if you are going too high or inclined too much, you are not doing what is expected for you, so you are getting a very bad reward. In all the other cases, let's see if we have improved the distance from your current position to the position that we actually want to get. Okay, so just let me show you that if you have a function, a definition, and you want to go to the definition of the function, then you control and click on the function, and then you get to there. Okay, so here it is. Then here is how we calculate the position, and the position, the desired position is here. It's where is it? Desired position, pose position. Okay, so what we observe here in order to calculate the reward is what is my current position and what is the distance from my current position to the desired position. And then based on that, it's very simple. We calculate a reward. That's it. So the question again is, but this desired position, where it comes from? So this position comes here to the beginning from here. We are putting it here, and it's a parameter also that we have included into the YAML file. So if you go to the YAML file here, you can see that we have a parameter that is called the desired pose. This is the place in the space that we would like the robot to be. So this is the problem that this algorithm is trying to solve. How can I go there to that pose without crashing and going as low as possible? This is the only and simple problem that we want the robot, the drone, to solve. And that is why we have done all that. Okay, so here we have also some parameters that you have seen: the maximum altitude, the maximum inclination that is allowed in order to say, hey, that's too much, the speed at which the robot is going to move, we have included as a fixed value, and then the amount of time that the robot is allowed to execute an action. So when we say, hey, please go forward or go left, then how much time are we allowing the robot to do this? Okay, so basically you have everything. Everything that you have is already here and explained. So then in the next thing, in the amount of time that it remains for us, we'll see if you have any questions. I just put it on the chat. And otherwise, what I would say is that I will provide you some homework to do. So you can do some experimentation, so you can change some values. And actually, I would like you to improve this algorithm, because this is just a simple version of the algorithm. I haven't even tried. I didn't have the time to try this for 1,000 generations. So I don't know if it's going to actually learn very good how to solve this. And this is a normal problem in reinforcement learning, that you have to try and see how it's going or not. So what I would say is that you try this for many, many generations, and then afterwards you modify the algorithm so you can improve the speed at which this robot is able to learn the task. For example, here you can see that when we take the observation that we provide to the learning algorithm is only the X position. So basically what we are saying here is that we don't care about where in the Y axis you are. We only care that you are forward. We only care that you are forward towards the point, but in the X axis. So that's something that you can improve. You can include here the X and Y in order to make the robot more self-aware of how far it is from the desired point. Another thing is that at present, we are not using the infrared sensors to detect this. Sorry, the sonar sensor. There is a sonar sensor in the robot here that, let me show you here. If you go to the shell and then you do a ROS topic list, you will see that there is a sonar sensor. Okay, so if this sonar sensor, you do a ROS topic info of the drone sonar, you will see that it's a type of range. Okay, so you can use that information and subscribe here in the environment, subscribe to that, and then get that information and provide that also as an observation to the system. So the system will learn to apply the information from the sonar to actually avoid the obstacle. Or you can also make that the robot is not only able to go to one desired point here that is very specific. That is the point that we have specified here in the YAM file. But instead, you make the robot be able to go to random points around any place. So the robot actually learns to go to a certain point. And this is very useful because you can provide this point in real time so that it changes every second. And by doing this, you will achieve a robot that is able to follow a point. And this point can be something that a detector is like a car, that a car is a detector of cars, so it can follow a car or something like that. So I propose you that you take this first, execute this for many episodes, so hundreds, and send me the images, the plots of the results, and let's see if it's improving the learning. And then if it is not improving, or you want to make it improve faster, try with different parameters or try those solutions, additional solutions that I have proposed to you. So then let's see on the chat if there is something. Okay, so any final questions that you may have? Is that clear? Have you understood how it works? Any question that I can answer in a couple of minutes? And then one question, is it possible to run the simulation as fast as possible, faster than real time? Yes, it depends on the simulation. And also, if you can close the, and now I don't remember if we can close this without crashing the simulation. I don't remember that, if it's available. So it's a good question, that, because if you don't have to render all the results as the robot is training, you can go a lot faster. Also, you can do tricks in your simulation to make it work as fast as possible. But this means that the simulation has to be tuned to that. So in order to go as fast as possible, then your simulation has to be optimized. Maybe, for example, you don't put all those elements that are around there. You simplify the environment. This element is not necessary, for example, because we want it to move forward, etc. And also, you avoid the rendering of the image. Like this, you can make it faster. Can you show us how to use the learned knowledge? That's a super good question. That's a super good question, Petrosu. And I think that this is the material for another OpenAI live show. Maybe it can be round 3, because that's very interesting also question. Yes, actually, you are already using it, because here, when you decide here to wait, is here, let me see, here, no, here, choose action here. When you are choosing action, here, your algorithm has already learned from the previous steps. So this action that you are selecting here is taking into account all the learning. So you are already doing it. You are using the learned thing, but I understand your question, Petrosu, that is, okay, so this is in learning state, but once everything has been learned, how can I save this and then just use it, just request that without having to learn? Then in that case, we can do that in another. Yes, it's simple. So you will skip this step here. You will skip that one because it's the one that does the learning, and then you just provide the state, and then it will provide an action, and then generate the step. That's it. So you will skip this learning step here. That's a way of doing it, okay? But you will need something more, because maybe you will want to save this value, the knowledge of this, for another program in another place. So, okay, so you got some answers now. So let's not answer everything. Martin, I don't understand your question. Can you create your own maps later? Your own maps of what? Maps of, sorry, I didn't say anything about maps. I'm lost. Then Petroshu, I already, is the one to call in a loop. Exactly. Choose action. Exactly. Once you have learned everything. Correct. Okay, so guys, I have to leave already. So I hope that this was clear and that you enjoyed to interact a little bit. And this is the way that we are going to do the next live shows. So I have to finish here today. But if you have more questions, put it beneath the video. Put it beneath the video, and I will answer them, all of them. So just put your question beneath the video, and I will answer. If you want to do the homework, and send that to me, so I will have a review and see how it works. And in case that you like this kind of videos, please give us a thumbs up, subscribe to our channel, and click the bell, so you will be notified every time that we are publishing videos like this, or of any other tutorials about ROS, that we are publishing one video every day. So you can get notified by subscribing and pressing the bell. You can get notified. And if you give us a thumbs up, that's really considered, because that makes us feel that our job is being accepted, and that you respect it. Thank you very much. So I see that there are some already, so thank you very much to all of you. And guys, let's see what we do for the next live webinar next week. So still not decided. Thank you very much. Thank you very much to all the people that is talking there on the chat, and see you next week. Thank you, guys. And yeah, so before I go, I think I should, for example, stop the sharing the here. Yes, so you can see me. And yeah, here it is. Okay, great. Thank you very much, and see you next week on another live show. We're going to solve many, many questions that people is asking. So if you have questions, go also to the down beneath the video and check. There is a link, so you can submit your questions for being answered in the next live show. Thank you very much. Cheers, guys.